Hey everyone, this is Manjunath for Data Science Galaxy. Welcome to my YouTube channel. Today, I'm pretty excited to talk to you all regarding the part 2 of the multi-part series on most frequently asked questions in data science and machine learning. Today, I'm going to be answering multitude of questions. If you are excited for this, please give it a like and subscribe if not already done, and stay tuned. Without much ado, let's get to the questions themselves. Shall we? Before we answer the first question, part 1 of the most frequently asked questions has been made available already on the channel. If you have not seen that already, please click the I button up above and see that video. There is a wealth of information and the answers I have provided to most frequently asked questions. Now, let's get to the first question in the part 2 of the video. What is the best way to learn ML algorithms? I'm quite sure this must be on top of the minds of many of the learners. From time to time, many learners reach out to me mentioning this, and I completely concur and understand where they're coming from. There is a wealth of information available out there in the public domain, but nobody would tell you where to start. What is the best way to learn machine learning algorithm? How do you go about in a structured and systematic way? So this is most important question for anybody to understand so that you will make the best of learning abilities that you have. So let us examine my proposed solution to the best way to learn machine learning algorithms. First and foremost, I strongly recommend learning machine learning algorithms by way of divide and conquer strategy. Yes, divide and conquer strategy. So I'm going to propose as a practitioner, as an experienced data scientist and consultant, a 4-step approach to handle and learn machine learning algorithms in a structured and systematic way. Are you excited to look at the steps? Look no further. Remember the structured and systematic approach that I talked about. Now let us check the step 1 and see what are the points that I've got to recommend for learning the machine learning algorithms better. First and foremost, one algorithm at a time by practicing multiple times on the data set. While learning, you take up a particular algorithm. Let us say you're going to take linear regression, for example. It could be in the language of your choice, could be in R, or could be in Python, or could be in any other programming environment. But the key is to take a data set, take one algorithm at a time. What do? You apply and practice multiple times on the same data set. Yeah, multiple times on the same data set. What does it do to you when you apply multiple times on the same data set? It will help you to understand the nuances of the algorithm. It's very, very important to understand the intricacies and the nuances of every algorithm that you work on. How do you go about doing it? Do not memorize. One more time, I'll repeat. Do not memorize. You look up for the syntax. You look up for the details and the explanation about the function or the algorithm itself. Do not memorize. That is where people make mistakes. They try to memorize. Human brain is not meant to memorize everything, and it is not worth memorizing everything. So what is my recommendation? Deliberate practice. Deliberate practice is the key. This I am again emphasizing, saying it from the perspective of my experience. Please perform deliberate practice, taking one particular algorithm on a particular data set and practice it multiple times so that it becomes muscle memory, second nature, and very natural to you. Yeah. Now let us look at the step 2 of my recommendation for learning the machine learning algorithms. What it entails. First and foremost, let us say you are going to take up a second algorithm, for example, logistic regression to learn. All you have to do is simply this. Follow step 1 that I talked about already a few seconds ago. A word of caution. This is where I see a lot of the learners in their eagerness to learn the algorithms faster make mistakes and not able to leverage methodic and systematic learning. What is that? Word of caution. Do not try multiple algorithms on a single data set all at once. Underline the word all at once while learning until you are comfortable with multiple algorithms. Underline until you are comfortable with multiple algorithms. This I'm saying from the practical experience. We will have enthusiasm to go about apply multiple algorithms without knowing individual algorithms in a concrete fashion, but would want to learn faster by applying multiple algorithms on a data set. We end up making mistakes because you will not be able to appreciate and leverage the learning better. So what I say, you should be resisting the temptation of application of multiple algorithms on a particular data set until you are comfortable with applying individual algorithms thoroughly, so that you could go ahead in an incremental fashion, one algorithm after the other, to learn. Yeah. Now let us see and understand what the step 3 that I want to talk about in terms of my recommendations to learn machine learning algorithms. I want you to be comfortable with multiple algorithms, following the approaches talked about in step 1 and step 2. Let us say, for illustration, you are going to learn 3 machine learning algorithms. One is logistic regression, second is, let us say, decision tree, and the third is random forest. Please realize some of these algorithms could also be used for regression, but let us say we are going to use for a classification setting. Now you are comfortable with the decision tree, logistic regression, and random forest. Once you are comfortable, what you would do next? Try these 3 different algorithms on the same data set. Hope you are able to appreciate what I'm trying to get at. You have learned individually decision tree, logistic regression, and random forest. Now we are comfortable with it. Now we are going to apply these 3 algorithms on the same data set for a particular context and setting. What you are going to do next? Voila! Now you are in a position to compare and contrast these 3 algorithms. By using what? By using model performance metrics. What is the purpose? To basically understand which algorithm or set of algorithms works better or suited better for which kind of a scenario. So here what we are doing, we have taken 3 algorithms that we are quite comfortable to apply in the same data set and use the model performance measures, let us say the classification metrics in this case, to compare decision tree with random forest with that of logistic regression, and we are able to compare and contrast and understand the intricacies in terms of which algorithm is the best suited under which conditions, why and why not. For learning, this is where it matters. Your ability to differentiate a particular algorithm and see which algorithms works better in which condition makes a huge difference for the application of the algorithms. Remember, nature of the data should lend itself logically to application of the algorithms. So your model metrics here and the understanding of the algorithms will keep you in good stead to make use of, let us say, a first go-to algorithm for classification could be logistic regression given certain setting. Then you could be going about looking at the rest of the competing strong algorithms. So this is how you are able to learn methodically the algorithms. We are left with one more step, step 4. Let us go ahead and examine without much ado. Shall we deep dive into that? Here is the last step that I'm going to make recommendation about. Before I talk about the last step, that is step 4, it is imperative for me to summarize steps 1 to 3. So what have we done? We have gone about learning systematically in a structured fashion multiple machine learning algorithms employing steps 1 to 3 so far. Are you going to stop at that? No, you don't. You go ahead and do what? You go ahead and benchmark the benefits and the limitations of each and every algorithm that you have learned. So let us say you have learned 3 algorithms, decision tree, random forest, and logistic regression. Now you are going to use the performance metrics and performance diagnostic to benchmark the benefits and the limitations of one algorithm over the others. So keep in mind, you as a data scientist is paid to solve a particular business problem. Let us say you're faced with a particular business problem of classifying customers into defaulters and non-defaulters. So what you do, you convert the functional problem into a machine learning problem. You take the data and explore the data to understand first the problem itself, then to see how about applying the classification models on the data for solving that particular business problem. So what you have in your repertoire, set of algorithms using steps 1 to 4. You've got decision tree, logistic regression, random forest, for example. These 3 algorithms you have, and you've also used the performance metrics to benchmark the benefits and the limitations. So now you go about in the form of selecting a particular algorithm after having understood the data using exploratory data analysis and application of unsupervised learning. Now let us say you're going to take up decision tree for the first algorithm. Why? Because you would know the data at hand lends itself to application of decision tree better. It's another matter, I'm not getting into it, the holy grail. Decision tree tends to overfit, but for an example, you would take decision tree. You also know the decision tree limitations. Then you go about looking at, let us say, random forest, which is a better method because which is an ensemble. Yeah, this way This structured and systematic approach to learning machine learning algorithms not just has given you hopefully a better way to learn the machine learning algorithms in an optimal fashion, but more importantly, it has increased your ability to solve business problems multifold for a given problem and setting in terms of bringing to bear the applied knowledge of several machine learning algorithms that you have learned and you're ready to apply on the business problem. So this is where I've come to the end of this first question. You can see how much of rigor I've put in to create this content for you, because I've used all my practical experience and my tacit knowledge to come up and concise this into a 4-step divide and conquer approach, divide and conquer approach strategically for learning any machine learning algorithm. So all in all, you could employ these 4 steps to learn any machine learning algorithm in any programming environment on any data set. One of the most frequently asked questions is also about data quality. People from time to time ask why, as a data scientist, one should care about the quality. I would want to ask you the same imperative question. Why do you care about the quality? Why data quality is paramount for a data scientist? Think about it. So before I answer specifically as to why would I care about data quality, or rather more pertinently, how do I ensure data quality, I want you to draw your attention on this slide to a few quotes. Let's start with the first one. This quote is particularly I've created. This is my quote. What does it tell? Tell me about your data quality, I'll tell you about your data culture. Very, very important to my mind. A single quote that depicts a lot about the data quality and the dire need for data quality, and as a consequence, it's a reflection of a data culture at a certain level. You could use this as probably one of the heuristics to look at data culture of an organization. Data quality is paramount. Remember, your modeling could be as good as the quality data that has gone into making that model. So what I'm talking about, I'm simply talking about garbage in, garbage out. Many of you must be familiar with this quote. If a model is fed with garbage, that is data that is of a suboptimal quality, what you could expect? The garbage. Absolutely right. The effort that has gone into building the model and subsequent decisions that you make would be suboptimal and costly in nature, which would simply mean the data quality at the source of it was the root cause, which you have not taken care. So this is yet another reason why anybody, and data scientists in particular, should care. Last quote but not the least. Here we go. What does quality data do to you? Quality data leads to quality insights, paving way for courageous decision making and the intended transformation. So, if you look at any organizations today making courageous decision using data and have taken leaps and bounds to make the transformation, at the heart of it is quality data, data mindset, data intuition, data culture, data literacy, data utility, etc., is what is driving. So, all these are a consequence of having a great quality data that is driving and powering your decisions to make the transformation and intended consequences. Hopefully, these 3 quotes will put into the perspective why anybody, particularly a data scientist, should care about data quality. Here is one more most frequently asked question, and that is, how do you ensure data quality? Please think about it. Very, very important question at the heart of modeling endeavor. So while answering this, I'm going to talk about this from the perspective of a culture, data culture, if you will, and data literacy. And I will look at data governance, and I look at from the involvement of a data scientist when you design the systems. So without much ado, let us deep dive into answering this and realize these are quite good indicators for one to go about looking at employing for ensuring data quality. Let us examine. What's the first one? Domain knowledge. Let me say emphatically, domain knowledge is indispensable for a data scientist, and more so in the context of ensuring data quality. Even if you want to identify certain issues with the data, you should be seeing it as a function of the domain. Of course, you should have data and domain knowledge for you to interpret the business insights and convert them into business impact. Goes without saying, but domain knowledge is foundational for ensuring data quality. So what else? The data culture. So what do I mean by data culture? I've seen organizations which uses data-driven leadership, that is driving the data culture from top down, are better poised to ensure data quality. Why? Because they have designed systems and processes that capture the data, which ensures the data quality by definition, by design. It is completely intentional. And I've seen many organizations where they use, let us say, ERP and CRM systems, customer relationship management, CRM systems. They have volumes of data about the customers, but the quality of the data is not to their liking, and hence they'll not be able to leverage the data for efficient quality decision making. What else we could do to ensure data quality? Data literacy and data utility paramount. If throughout the organization, if the management enforces the data culture from top down, and you have employees who are data literate, who are understanding the utility of the data, then you are able to come up with most optimal system designs to capture the data, which lends itself later point in the journey of the organization to make efficient and optimal decision making, which is time bound, which gives you a competitive advantage. So what else you could do? Most importantly, you could be looking strategically, committing certain resources. Realize quality of the data is not free of cost. It comes with a cost, and you have to incur cost as an organization upfront in the organization to ensure data quality. So you got to commit certain resources, certain cost for committing the data quality. And more importantly, you should be involving data scientists from the beginning who has got data literacy and data culture, data intuition, data understanding, etc., so that it is integral to designing the systems for ensuring data quality. It is another matter. You could have a lot of processes around data quality and data governance for you to ensure the compliance to certain data quality. Some of the points that I want to talk about and leave you with is to excite you to think more about how does one go about data quality. By the way, I'm interested to look at and understand what else you would do to ensure data quality. Please leave your thoughts and comments in the comment sections down below. From time to time, people also reached out and asked me to share my learning experience with the data. So, as a seasoned data scientist and mentor working on several data science problems day in and day out for a livelihood, I want to share a lot of the learning experiences with the data, particularly my learning experiences. First and foremost, I would say from my experience, is experiment with the data. This I recommend to beginners, enthusiasts, or for that matter, seasoned data scientists. There is no alternative and substitute for experimenting with the data. You've got to be spending time with the data. Take a problem, take a data set. It could be a toy data set in the initial stage for learning. Start experimenting with the data. Realize data science is a highly applied field. That simply means take the data set, apply, let us say, exploratory data analysis, including data discovery techniques and visual analytics, not just numerically look at the data, but also look at the data graphically for distributions explore further. So experimenting is at the heart of data analysis. This is my first experience. Second has been, if I have to say, you have to be data smart. What data literacy, data culture, data utility, data intuition, and learning machine learning algorithms all should lead you to become a data smart data scientist. What it would do, you should avoid at all costs what is called HIPPO, HIPPO, stands for highest paid person's opinion. So let me go to the extent of saying, if we do not have data, if we do not have data backing your decisions, all you have is going about somebody who is highest paid in the organization, that person's opinion. Simply put, in the absence of data, all you have are opinions. So this has been my learning experience. When you sit for a meeting, let the data do the talking, let there be empirical evidence. Don't just go by some people who are highest paid, for example, with the due respect to them, with purely by their opinions and intuitions. So what else in my experience? Do not try to please everyone with the data. It is almost impossible because many people choose to go by intuition, go by gut feel, etc. So it's difficult to please everyone with the data. So that said, you should not stop using data to make a point strongly at that and persuasively communicate in such a fashion that you'll be able to turn them around, and instead of being going purely by gut feel or intuition, they would also seeing value from the data. So what else in my experience of learning with the data? Do not be economical with the truth. I've put it as a last point. This is not the least by any stretch of imagination or by any standards. What data says, dispassionately talk the language of data, of course, in the context of the domain, the setting, even if it is contrary to the intuition, contrary to the opinion of even the leadership or any stakeholder for that matter. So do not be economical with the truth. For me, Data is the truth. Data are facts. So don't be economical with the truth. So I'll share more the learning experience in the next slide. Continuing with my learning experience with the data, I would say data are a potential solution to a problem to my mind. Why do I say this? Please remember, with the data, you have a potential solution to your problem, and problem is then your opportunity to give your best using the data, come up with an optimal time-bound solution that gives you a better advantage at the marketplace. So what else I want to share as part of my learning experience with the data? I mentioned earlier, a few seconds ago, if you will, regarding people use intuition even now and go about gut feeling. So I would say instead of using intuition or gut feeling for that matter, please use data and become at least 1% more accurate over your intuition so that you will have a better chance of making decisions, which gives you higher probability of success. So what else in my learning experience? I would say at the end, have fun with the data. Data is fun. Data analysis is fun. It is said if you're doing something wrong with the statistics, then it is nothing to do with the data. Data will never be boring. It is something that you have used wrong statistical technique to analyze data, or you have not understood the problem better. So for me, data is fun. Data is the answer to several questions. So data has the potential to come up with an optimal solution. Data has gives me the strength to be more accurate for my intuition. Data gives me the edge. So with this, I've come to end of this video. Hope it was useful. Please give it a thumbs up, share it with your friends and your network. Subscribe if not already, and stay tuned for more. Don't forget to hit the bell for notification whenever we release a video. This is Manjunath signing off. Thanks for watching, and bye bye. I'll talk to you in my next video.